class, welcome back to my YouTube channel, and for today I'll be your teacher in general mathematics, and our lesson is about the lesson 16, graphing exponential functions and the properties of the graph. So from our previous topics, which we've already discussed, we defined the exponential functions, and we also discussed the different ways to represent the functions itself. So we have 4 ways to represent the relation slash the functions. So we have 4 ways: the equation or the function itself, the graph, the table of values, and the ordered pairs. So in here, we need to graph those exponential functions, and we are going to represent on our solution by representing the exponential functions by representing it in table of values. And of course, we need to describe its properties. So we are going to determine what are those properties of the graph of our exponential functions. So from our previous lessons in rational functions, we have the properties of the graphs, which are the asymptotes, the zeros, intercepts, and so on. So for us to do that, let's have examples. So first, we have example 1. Problem: sketch the graph of f of x equals to 2 raised to x and g of x equals to 1/2 raised to x, and describe the behavior of the graph. So in order to sketch the graph, we need to first need this first step. So the first step for our solution, we need to construct the table of values of the ordered pairs for the given function. So we have 2 given functions. We have the f of x and the g of x. So we need to construct the graph of those 2 functions. So let's first have the table of values by getting the ordered pairs. So let's assume let's solve rather. So for the first solution, so we have the first function here, the f of x, which is equals to 2 raised to x. So assumption in here that your domain is the domain is the set of your x values. So we can assume that these are all we can say that one of the properties of the exponential function, which is in the form of f of x equals to b, or the base, raised to x. So the domain is or are the set of all real numbers. So let's get from those real numbers. Let's say from -2. Let's start from negative values to positive values. So let's say -2. So we need to substitute -2 to our function. So f of -2, that is equals to 2 raised to -2. So our x is -2. So this is equals to 1 over 2 raised to 2. So when we have negative exponents, so this we can apply the property of negative exponents, so it can be written in the denominator. So we have 1 over 2 raised to 2, and 2 raised to 2 is equals to 4. That is equivalent to 1/4. Next, we have -1 as the value of your x. So let's substitute f of -1 equals to 2 raised to -1. That is equals to 1 over 2 raised to 1. So this is the same with what I've said, property, law of negative exponent. So this 1 over 2 raised to 1 is also equivalent to 1/2. So when our x is -1, the y, or the range, is 1/2. Next, we have 0 value. So we have negative values for your domain and the 0. So we have f of 0 equals to 2 raised to 0. So anything that we raise, or any value that has an exponent of 0, any expression that is equals to 1. So next, let's have positive values. So we have positive 1, so we have f of 1 equals to 2 raised to 1. So 2 raised to 1, that is equivalent to 2. So this is an identity. Next, we have f of positive 2 equals to 2 raised to 2, that is equals to 4. So now, let's have the second function, which is the g of x, which is equivalent to 1/2 raised to x. So this time, we can use also the domain that we've used in the first function. So we have from negative 2 to positive 2. So we cover the negative sides, negative real value, negative integers, the 0 and the positive integers. So those are real numbers. So g of negative 2, we have 1/2 raised to negative 2. So in here, when we have a negative exponent of your fraction, we can simply turn it to its reciprocal. So we have 2 raised to 2 over 1 raised to 2. So we have 2 squared, that is 2 squared. So 1 squared is just also equals to 1. So we have an imaginary over 1 here. So 2 squared is equals to positive 4. Next, let's substitute negative 1. So we have g of negative 1 equals to 1/2 raised to negative 1. So again, let's get the reciprocal. So this is also part of law of negative exponents. So we have 2 equals to raised to 1. So we have 2 raised to 1 over 1 raised to 1. So 2 raised to 1 over 1 raised to 1 is equals to 2 raised to 1 also, which is equals to 2. Next, we have g of 0. We have 1/2 raised to 0, that is also equals to 1. As I've said earlier, anything that you raise to 0 is equals to 1. So we have g of 1, we have 1/2 raised to 1, that is also equals to 1/2. And last, we have g of 2 equals to 1/2 raised to 2. So we both raise the numerator and the denominator with the square. So 1 square, that is 1, and 2 square, that is 4. So we have 1/4. So for the table of values, we need to get this ordered pair. So we have negative 2 as your x, and then 1/4 as your y, or your f of x. So we can write it in this table. So we have negative 2 as your x, then we have 1/4, then negative 1, we have 1/2, 0, we have 1 here, then 1 we have 2, then 2 we have 4 as your y. So for our g of x, we have 4, 2, 1, 1/2, and 1/4. So the next step to solve or to graph these functions, we need to plot the points or those values in our table on a Cartesian plane and connect the dots in forming the graph of the function. So let's do that. So we have this table of values earlier that we've got, that we've computed. So we need to plot this in a graph. So if you will see it in your module, kindly get your module. So we have negative 2. So here is your x, negative 2. We have positive 1/4. So we have this plot or dot. Next, we have negative 1 and 1/2. So we have this dot. Then we have 0 and positive 0 for your x. So we have this 0. And we have 1 to your y. So we have this plot, this dot. Then 1 as your x, then 2 as your y or f of x. So that is here. Next, we have 2 for your x and 4 for your f of x. That is here. So this is the graph. This red smooth exponential graph is for your f of x. For our g of x, we have negative 2 and positive 4 for your y. So that this is the dot. So we have negative 1 and positive 2. So this is our dot. So we have 0 for your x and 1 for your y. So this is your graph. This is your dot. Then this is for x, we have 1, then 1/2 for x, for y rather, for f of g of x. So we have this point. And last, we have 2 for x and 1/4 for our y or g of x. So we have this point. So this black smooth curve is the graph of your g of x, which is equals to 1/2 raised to x. So what are the properties of that graph? So we have a specific f of x equals to b, which is the base, the 2, and the 1/2 raised to x. So here are the properties of that exponential functions. Of course, the graph. So as I've said earlier, let f of x g equals to b raised to x, wherein your b is greater than 2, 1, and not equals to 1. So we have 2 and 1/2 here. So the specific graph that we are talking here is just the f of x, which is equals to 2 raised to x, because that is the b greater than 1. So we have 2 as your base. So the properties of f of x equals to 2 raised to x are, so first we have the domain is the set of real numbers. So those are from negative infinity to positive infinity. So as we have the domains, of course, we have this range, which is the counterpart of our domain. So the range is the set of all positive real numbers. So if you're going to look back on our table, so the values is from 0 to positive infinity. So we have another properties. So third property, so we have if b is greater than 1, then f is an increasing exponential function. So we have observed earlier that the f of x is an increasing function. That is the red curve. That is the red graph, the f of x. And if your b is from 0 to positive 1, so an example earlier is the g of x, wherein your base or your b is 1/2. So it's in the middle of 0 to 1. So your f, your function, is decreasing exponential function. So if you're going to look back in that graph, the graph is a smooth curve. It is smooth decreasing exponential curve. So we have the black curve. And we have the fourth properties. The function passed through the point 0, 1. So again, because if we substitute your x as 0, so we have an exponent 0 that is always equals to 1. So your function should pass through the point 0, 1. Fifth property, we have the y-intercept that is equals to 1, and we have no x-intercept. Always remember that. And for the last, we have the last properties. The graph approaches but does not reach the x-axis. So meaning, the x-axis is the horizontal asymptote, which is y is equals to 0. So we have an horizontal asymptote, which is y is equals to 0. But there is no vertical asymptote. So those are the properties of the exponential functions in the form of f of x equals to b raised to x. So it should not, your b should not be equals to 1.